Good morning everyone. This is third video regarding two methods for expressing concentration of the solution. Now we have another method. This one is mole fraction. Again, this one is also very important for your exam point of view. Okay, now this one is mole fraction, and mole fraction is represented by chi. Actually this one is chi, and don't say chai again. Okay, this one is a simple thing. Okay, chai. Actually it looks like x. So nowadays in books generally they will give you x also, so you can make it as x, but it's not a x exactly. Okay, it's a capital version of like this x. Okay, now but this one is known as chai, chie. Okay, so this one how to represent mole fraction. Okay, now basically mole fraction is the ratio of number of moles of one component to the total number of moles present in the solution. Means suppose, okay, that for formation of a solution, okay, generally we have two components only, 1 and 2, so a plus b. Okay, when both combine, okay, then they form a solution. Generally two components are present in this one. Then the ratio of number of moles of any one component, either it's a either it's a b, okay, to the total number of moles present in the solution. Total number of moles means that is for a and b. Okay, now in this one how to express it. Now suppose it's a mole fraction is equal to total number of moles of a upon total number of moles. And how to write it? Now mole fraction of a is equal to Na upon Na plus Nb, because this one is total number of moles. And suppose instead of a, if you have to calculate, that one is you have to calculate for b. Okay, so in this one that is Nb, because it's a number of moles of one component, maybe it's a b, upon total number of moles, Na upon N, Na plus Nb. So this one is also there. So how to calculate mole fraction? With the help of this formula. And this one is easy, because in this you have to calculate only number of moles. And how to calculate? That is given mass upon molar mass. You know how to calculate molar mass. Okay, and given mass obviously it's given to you in question. Now in this one is mole fraction. Now one question related to mole fraction. Okay, acha, in this one generally calculations are lengthy, but calculation obviously you have to calculate. Now in this one question, a solution is 25% water, 25% ethanol and 50% acetic acid by mass. Calculate the mole fraction of each component. Okay, now remember one thing, whenever things are given to you in percentage, so your first work is you have to consider, कुछ suppose करो. Okay, so let the total mass of solution is equal to 100. Okay, so our total mass is equal to 100, and when you calculate 25% of 100, so obviously it's a 25. If it is 50%, so it remains 50%, but it remains 50. So just see, mass of water, we'll take it as A, it's your wish. You can take it as XYZ, KLMN, it's your wish. Okay, so water A is equal to 25 gram. Why 25 gram? Because 25% of 100 is equal to 25. Now mass of ethanol, it's a 25 gram. Again, as that mass of acetic acid, I am taking it as a C. Okay, so this one is 50 gram. In this mass given to you, now you have to calculate their molar mass. The molar mass of ethanol, it's a 46. How? That one is ethanol. Formula of ethanol is C2H5OH. Okay, now in this one calculate this, so it's a 46, and acetic acid, it's a CH3COOH. So this one is 60. And regarding to water, molar mass of water is equal to 18, because formula of water is H2O. Now in this one you have to calculate number of moles for all three. So first of all, Na, so it's a 25 upon 18. This one is 25 upon 18, given mass upon molar mass. Calculate it. Okay, calculation will take time. Okay, so obviously you have to give time to calculation. Now Nb, it's a 25 upon 46. After calculating this, answer is 0.543. Now Nc, this one is 50 upon 60, so 0.833. Okay, this one is your number of moles. Now with the help of this you can calculate number of Okay, you have to calculate mole fraction. Now total number of moles, add all three, and now calculate mole fraction of A. So it's a number of moles of a component, it's Na upon total number of moles. To put these values, answer is 0.502. Okay, now mole fraction of B, same, Nb upon total number of moles. So Nb is 0.543, already calculated. This one is total number of moles, your answer is this, and last one is C. So number of moles of C is equal to 0.833 upon this one is again total number of moles, already this one is already calculated. So after calculating this, answer is 0.302. Okay, so this one is how to calculate number of moles. Now one general question, because now we have learned formula of molarity and mole fraction. So one combined question. Okay, now just see. Another one is a solution of glucose in water is labeled as 10% W by W. It's a okay. Now W by W means basically it's given percentage by mass. The density of the solution is 1.20. Now here its density is given. Okay, gram per ml. Now calculate molarity and mole fraction of each component. Okay, now your first work is whatever you have to calculate. Okay, you have to calculate in all three number of moles, and for number of moles हमें क्या चाहिए, molar mass. तो सब चीज़ calculate कर लें एक साथ. Okay, now start. First of all, percentage is given, so you have to suppose. Now 10% solution of glucose means that 10 gram of glucose is present in 100 gram of solution. Okay, solution in 90 gram of water. Total is 100, so in 90 gram 10 is added. Okay, now for first one, calculate molality. Okay, for this one, Nb upon Wa into 100. Okay, this one is 1000, it's not 100. Okay, now it's 1000. Number of moles of B upon Wa. Now you have to calculate number of moles. How to calculate? Mass of solute means glucose is 10 gram, because percentage is given. Now molar mass of glucose is 180. Either you will learn 180, otherwise you have to calculate. Formula of glucose is, you know, formula of glucose, that one is C12H22. This one is C12H, sorry, it's a glucose, C6H12O6. This one is glucose, so your formula is C6H12O6. Now you have to calculate. So after calculating this, answer is 180 gram. Calculate number of moles. It's a 10 upon 180, and answer is 0.0556. Now in this one, number of moles calculated. Now put this value. Okay, molality, mass of solvent is 90. Now molality is equal to 0.0556 upon 90 into 1000. Okay, after solving this, your answer is 0.618. Now another one is you have to calculate molarity, the number of moles of solute upon volume of solution. But here it's not given in, obviously, in a liter, so you have to multiply this term with 1000. The formula is written here. Density is given, but okay, volume is not given to you. So how to calculate volume? Volume is equal to mass upon density. Okay, put values. 100 upon this, density is 1.20. Now after solving this, answer is 83.3 ml, and substitute all the values in your formula. So this one is number of moles of solute is this 0.0556 upon 83.3. After calculation, your answer is 0.667 m. Now last one is you have to calculate number of moles. How? Number of moles. Okay, now in this one, number of you have to calculate mole fraction. Okay. Now just see, for this one, for calculation of mole fraction, you have to calculate again number of moles, because for glucose we have already calculated, but for water you have to calculate. Now just see, total moles is equal, now in this one, that is Na, because now this one water is a solvent, so 90 upon 18, because molar mass of water is 18. Now this, after calculating 18 into 5, that is equal to 90. So your answer is Now just see, your answer is 5. Total number of moles, that is equal to 5 plus 0.0556. Now calculate mole fraction of glucose. So n glucose upon, okay, total number of moles, it's a glucose plus water. So after calculating this, your answer is 0.011. Now you have to calculate for water. So water, that number of moles of water upon total number of moles, so it's a 5 upon 5.0556, that is equal to 0.989. Now one question is for you. That one is, a sugar syrup of weight itna contains 34.2 gram of sugar. Actually it's a sucrose, formula is given to you. Now calculate molar concentration and mole fraction of sugar syrup, ठीक है, sugar in the syrup. Okay, thank you.